Hi, welcome to Pathways to Chemistry. This is Dr. O'Connor, and today we're going to talk about isotopes, and then we're going to talk about atomic mass. First, let's define an isotope. Isotopes are atoms of an element that have the same number of protons but differ in the number of neutrons. That means they have a different mass number. Recall that A is the mass number and equals the sum of the protons and the neutrons. Z, recall, is the atomic number, and the atomic number identifies an element. Many of the naturally occurring elements are actually composed of isotopes. And again, isotopes only differ in the number of neutrons. Let's look at carbon, for instance. It has two stable isotopes, carbon-12 and carbon-13. Carbon-12 has 6 protons and 6 neutrons in the nucleus. Carbon-13, however, has 6 protons in the nucleus and 7 neutrons. We know that these are both carbon atoms because they both have 6 protons in the nucleus. They only differ in their mass number or in the number of neutrons. In order to represent isotopes, we use isotopic symbols. We write an isotopic symbol by writing the element symbol, and then in the upper left-hand corner as a superscript, we write the mass number, and in the lower left, as a subscript, we write the atomic number. I can also represent a chlorine atom that has 17 protons and 18 neutrons in the following ways. I can write the element symbol with a hyphen and the mass number. I can write out the element name with a hyphen and the mass number, or I can have the isotopic symbol with just simply the mass number. That is enough information for me to identify that particular isotope. Let's look at a problem. Consider the isotope symbol for the unknown element X. So we don't know what X is, but that's easily found. Remember, this number here corresponds to the mass number, the sum of the protons and neutrons, and this number here corresponds to Z, the atomic number. So all we need to do is look up the atomic number 12 on the periodic table, and we can identify the elements. So we've already got part B answered. We look up the atomic number 12 on the periodic table, and Z equals to 12 is the element magnesium. So now in part A, I'm being asked how many protons and neutrons are contained in the nucleus of this isotope. Well, I know from Z that there are 12 protons, and the mass number tells me that the sum of the protons and neutrons is equal to 26. So if I subtract Z from A, the mass number, I get 14 neutrons. Let's take a look now at the difference between atomic mass and mass number. Recall, the mass number is the sum of the protons and the neutrons. So mass number is always going to be a whole number. We don't deal with a third of a proton or a half of a neutron. So the mass number is strictly the sum of the protons and the neutrons, and we do not find the mass number on the periodic table. The atomic mass, however, which we find on the periodic table, and notice it's always in decimal form, this is an average mass in atomic mass units of all of the naturally occurring isotopes of an element. Recall that elements can have 2 or more isotopes, each with different mass numbers. We cannot simply just average the mass of each isotope because each one occurs in different abundances in nature. Each isotope, in other words, has its own contribution to the atomic mass. So in order to calculate atomic mass, we need the percent abundance and the atomic mass of each isotope. What we calculate is what we call a weighted average atomic mass. So let's take a look and see how that's done. So in this problem, we're told that the imaginary element X has 3 isotopes, and we're asked to calculate the weighted average atomic mass of element X using the information in the table. Recall that in order to calculate a weighted average atomic mass, we need both the atomic mass of each isotope and the percent abundance of each isotope. We cannot simply take an average of the 3 masses in this case. The first thing I need to do is convert percent abundance to fractional abundance. And how do I do that? I just divide each percent abundance by 100. So if I divide 90.5% by 100, I end up with 0.905. 0.27 by 100, I end up with 0.0027. And 9.2 divided by 100 will give me 0.092. So these are the fractional abundances. Now, what I need to do next is multiply each atomic mass by the fractional abundance. So let's start with X20, and the atomic mass is 19.992, and I multiply that by its fractional abundance, which is 0.905, and I end up with 18.093 atomic mass units. I do the same thing here for X21, and we have an atomic mass of 20.994. I multiply that by the fractional abundance, 0.0027, and I end up with 0.05668 atomic mass units. And let's do the same thing for X22. We have 21.991 atomic mass units times the fractional abundance, 0.092, and I end up with 2.0232 atomic mass units. Now what I want to do is add these three values, and that will give me the weighted average atomic mass of the elements. So I have 18.093 atomic mass units plus 0.05668 atomic mass units plus 2.0232 atomic mass units. And that gives me 20.17 atomic mass units. I'm just keeping two digits to the right of the decimal point. Later I'm going to show you how to figure out how many digits you should retain, but for now we'll just keep two. Now, if I would have simply just averaged these three values here, let's see, I would have gotten 19.992 plus 20.994 plus 21.991, and then divide that by 3, I would have gotten 20.99. And that would have been very different from the weighted average atomic mass. Let's take a look at what happens when atoms lose or gain electrons. When an atom loses or gains an electron, it becomes an ion. So let's take a look at the definition of an ion. An ion is a charged atom with an unequal number of protons and electrons. Recall that a neutral atom has an equal number of protons and electrons. For example, the lithium atom contains 3 protons in its nucleus and 3 electrons in the extranuclear region. This would correspond to a neutral lithium atom. You have 3 negative charges from the 3 electrons and 3 positive charges from the 3 protons. So you have an atom that is neutral. There is no net charge. Now, let's say that the lithium atom loses 1 electron. Well, in that case, you will still have 3 protons in the nucleus, but only 2 electrons in the extranuclear region. So that means that you'll have 3 positive charges and 2 negative charges. So the net charge is going to be a +1. A cation is a positively charged ion. And in this case, when the lithium atom loses an electron to become the lithium ion, it is a cation. Now, atoms can also gain 1 or more electrons. And when an atom gains 1 or more electrons, we call it an anion, and this is a negatively charged ion. So we have to use symbols in order to represent ions. When an atom becomes a cation, we write the element symbol and then we write the charge. So magnesium will lose 2 electrons to become the magnesium ion. If a magnesium atom loses 2 electrons, it's going to have a positive charge and it's going to be a positive 2 charge. If a sulfur atom gains 2 electrons, we're going to write the symbol for sulfur. And when an atom gains 1 or more electrons, it is negatively charged. So because sulfur gains 2 electrons, it has 2 more negative charges than positive charges. So we write that as sulfur 2 negative as a superscript. We'll talk more about ions later in class.